It just means that like as the sample size increases, it's going to be closer to your expected result. So if you flip a coin, you're not going to get as close to the mean. In theory, you wouldn't get as close to the mean expected result as you would if you flipped like 1,000 times.
Right. Perfect. What else here? If asked, so if we're asked like, what is the mean of the distribution of sample means? It's the same number. So the distribution of sample mean equals the mean of the distribution.
Wait,
Does that make sense?
that makes sense to you? It is? Sorry, I was kind of zoning out. Wait, can you say it one more time?
So if there's a question that asks what is the mean of distribution of sample means? You know, there's a sample mean, the distribution of sample means, and then there's the mean.
Yeah.
And it says what is the mean of the distribution of sample means? It's the same number. We don't have to calculate that. It's the same exact number. And then, do you guys know how to calculate standard deviation of distribution of sample means?
Yes. That's the standard deviation divided by the square root of the sample size.
Yeah. Perfect.
Okay.
All right.
Sorry, that's what I thought you were talking about, which is why I was a little confused.
What else you guys? What else in the chapter you guys want to talk about?
I don't know. We didn't get too much time to look at it. We were just looking at it just before we got on the call because we've been driving, but
right.
I don't. Oh. What question? Oh, I think I figured it out. It's just like the of the sampling distribution. Is that what it is? Is that what it's called?
What about? Yeah.
Yeah. I was just wondering, like, that's basically like margin of error, right?
Standard deviation of distribution of samples.
Error? Like, I'm trying to figure out what that number is.
I'm not sure if that's associated with margin of error. It didn't say anything about that in the chapter, did it? I don't remember it talking about that in the chapter.
It doesn't. I was just wondering if that's what it was. I don't know. Because it doesn't matter.
I don't know. Sorry. Okay.
He's giving the dog right now. So, sorry, it's like bad timing today. I apologize.
No, you're fine. You're fine. I understand life is kind of crazy, so.
It has been a crazy day, I'll tell you that. So, okay.
Should we, do you guys have any questions about, like, as far as the preparation stuff?
No, we haven't really done the preparation. We were looking at the videos right before we looked at it. And just kind of going through and reviewing and stuff.
Right.
This kind of like is a little more confusing than the last one, but like.
Yeah. Understandable. See here, what else do I have in my notes that'll help? Yeah, it's like kind of all I got. Well, whenever he's ready, I think we should just start the quiz and see what we do from there.
Sounds good. It's a lot of stuff. I'm like recording right now. I can stop recording and then restart it if we want to do that. Do we want to do that or?
Well, how long is he gonna be?
Just like probably like 2 or 3 minutes. Should be good.
Yeah, we'll just keep going. You can just look over your notes. I'm just gonna keep looking over my notes.
Okay.
So here's a question. Ready? What
Okay.
is the shape of a distribution of sample means when the data are not normally distributed, but the sample size is large?
I didn't hear.
So, what is the shape of the distribution of sample means when the data are not normally distributed, but the sample size is large?
Bell curve? Is it bell curve? No?
I think so.
Nothing?
I haven't looked at the answers. I just filled them in like what I thought. And we'll go check it out real quick. Hold on.
Okay, let me see. Normal. Okay, not a bell curve.
Well, bell curve's normal. As long as it's symmetrical, that's normal, right? The bell curve is normal. So if it's left skewed or right skewed, it would be abnormal.
Okay.
I think.
I thought they were different things, but they may be the same thing.
Look at it.
Let me see. Let me Google it.
I've actually had
Hold on.
Like them. I don't know what his mindset is tonight. I don't know. It's weird. The story is like he got this dog and he didn't do any of the paperwork or see if it was okay with our apartment complex.
Oh, perfect.
And so we had to get rid of him. It's a little sad. He's a really cute puppy. Dog too. Got it all? Sure.
Yeah. Just need the
There was nothing in the back. Okay.
Nope. All right. Sorry.
You're fine.
Cold out there. Where's my lap? Okay.
Okay, you guys ready? Do you want to go over anything else before we start this quiz?
I'm gonna get on yours. He's gonna get on mine. Okay. He's gonna get on his computer.
I'll just do it here. It's no big deal.
Do you want to just get on mine? Maybe since I'm on yours. Or do you want to switch?
You can just keep going.
Yes, that's what I'm saying.
That makes sense.
Okay.
I see why you're confused. You just log out and I'll just log in on my phone.
Okay. Sorry.
You're fine.
1 second.
The struggle is real.
No idea.
Okay. Group quiz. Start quiz. Okay. Okay.
Okay.
All right. All right. Here, taking sample size of n equals 5. What is the shape of distribution of means histogram when the parent population is right skewed? It's going to be skewed right. Right?
Yeah, because it's Are you on the right one?
Yeah. I thought it was opposite.
Skewed left?
It's skewed right.
So sample size n. So n equals 5. So sample size equals
Right.
5. What is the shape of the distribution mean histogram when the parent population is right skewed? Which is
Oh, I guess it's gotta be right. Yeah. Yeah.
It says it right there.
No. That's not what I was worried about. I was thinking about something else.
I'm just going with my notes to make sure I did that. The standard deviation, blah, blah, blah. Alright. Sample size is only 5. It still would be skewed right. If it was over 30, would make it.
It'd be normal.
It'd be normal. Okay.
That's
I think.
So then the next question is
yeah.
So when you take a sample size of 100, what is the shape of distribution means histogram when the parent population is right skewed? That would be normal, right?
Yep.
correct.
And when you're looking at sample size n, what's the shape of distribution histogram? The parent population is normal distributed. That would be normal as well.
We got 3 straight normals.
Well,
Question
number
6
3
is
skewed right. Oh, next one. Can you talk about the next one?
yeah.
So you,
The same thing, just normal.
What's the shape of distribution histogram when the population is normally skewed? Normal. Okay. When would a distribution of means be normally distributed? Okay.
Choose all.
So data are drawn from population is normally distributed by sample size is small. No. Sample size is large, so click the next one.
Well,
data is drawn from. Go ahead.
Wouldn't it be the first one too? Because it's normally distributed and the sample size is small, so it's going to be normally distributed.
No. So, oh wait, data are drawn from population that is normally distributed. Yeah, actually, you're right. Because even though it's small, it's still normal.
Yeah.
So
Yeah. And then the rest should be just the ones that are large.
Yeah. Data drawn from population that is right skewed. So it's everything but the third one, right?
Yeah.
Data drawn from population skewed, sample size small. Okay. Which of the following gives the best explanation of the central limit theorem? I have the definition over here. The greater the sample size, the closer the data will. Okay. The greater the sample size, the closer the data will be normal. That's pretty much what I wrote down. So, its population. Which data are drawn as normally distributed? Simple mean. Size is large.
The third one? No, wait. The last one.
Sample size is
Yeah, it's the last one.
approximately normal. Correct.
Equal.
The greater sample size. I think it's the last one.
Yeah,
Yeah.
I agree.
Okay. Using the following information to answer the next 4 questions. Let X be random. So what does X stand for again?
Sample size? No, N is sample size. X is.
No, that's not me.
It's a random variable. We don't know.
And I'm going to look for the thing real quick.
What's the mean?
X
Oh, no.
Isn't 9, 10?
What? So X doesn't matter. It's just saying like X is like a random variable instead of giving you a story question. They're just saying X is a random variable.
The population mean of U equals
U.
100. Population size. Population standard
Oh, wait.
deviation 6. Suppose the sample size of 36 is drawn from this population. What is the mean of distribution of sample mean?
It's going to be 10, right?
Yes.
Okay. I thought you were talking about question 10.
Sorry, no, I was saying 9.
Yeah, my bad.
What is the standard deviation of distribution of sample means? That's where you have to go. Standard deviation
1.
divided by square root sample size.
Mhm.
Yeah.
So
That's 1.
So standard deviation is what?
6, so it'd be 6 divided by the square root of 36.
So 6 over 6 is 1.
Divided by square root. I'm just gonna do
Oh, this is a short quiz. Dope. 12 questions. Let's go.
Where we're at? We're at 6 divided by the square root of 36.
36.
What'd you guys come up with? Kind of type. Okay.
We just came up with 1.
Yeah.
Yeah, same thing I got. Okay, 11. Regardless of the distribution of the sample population, if the sample size is large and is greater than 30, what would be the shape distribution if the distribution of the sample mean? Normal. Right? If it's greater than 30, sample size is greater than 30.
Yeah. Yeah, I got you.
So what theorem would justify your response to the last question? Freak. Confused.
The central limit theorem.
The greater the sample size, the closer the data will be to normal. Or a large number of sample mean will get closer to the population mean as sample size goes up. Standard deviation.
I believe it's.
Well, why would you say that? What's the difference?
Because central limit theorem has to do with the distribution as opposed to the expected results or the mean that you're expecting to get for the law of large numbers. So, like, I'm pretty sure that the definition of the central limit theorem is just based off of the distribution specifically.
Oh.
Or do I have that backwards?
So law of large numbers says sample mean will get closer to the population mean as sample size goes up and standard deviation goes down. And then, so sample mean will get larger. Maybe it's law of large numbers.
Yeah, I kind of thought this one was different. Never mind. I don't know anymore.
What theorem would you just response to the last question? Freak, I don't know.
Here, let me,
he went over the difference in the very end of the second video. Let me just look at it real quick. It's all right.
Sampling distribution of the sampling means approaches the normal distribution.
Yeah. So essentially, yeah.
So
It is the central limit theorem.
The central one?
Yeah, because the definition is the sampling distribution of the sampling mean approaches a normal distribution as the sample size gets larger.
Yeah, but look at the large numbers. Law of large numbers. The sample mean get closer to the population mean as sample size goes up.
Because the law of large numbers doesn't talk about distribution.
You're right.
Does it?
Right. No, let's try it. Let's do it. I think you're right. Central limit theorem. Save responses. Here, I'll submit it first just to see how it goes. I'm scared.
Oh, I get the difference. because the central limit theorem like means that it's talking about all the data being uniform versus just the mean being in the middle. Supposed to be. If that makes any sense?
Oh, all right.
No.
Sweet. It's all right. It's all good.
Dope.
Awesome. That was fun.
That was quick and easy.
So I was talking to, I had a short meeting with the teacher, and she just to kind of go over some of the stuff that I missed last week.
Yep.
And she said lesson 7 is super hard. So she said make sure you study it really well.
Okay.
She said lesson 6 is just like a intro to lesson 7.
Okay.
Lesson 7 is gonna be pretty hard, and I think we have a test this weekend, don't we?
That's a good question. Let's see.
For sure. Lesson 7. After lesson 7 homework quiz.
I don't see a test.
Oh, it opens on the 30th and ends on the 1st of February.
Oh, yeah, I see it. It's in lesson 8.
30th. Yeah, so it's next Monday through Wednesday.
Yeah. Okay.
So I don't know. Anyways, just a heads up so when we come together on the maybe a little bit more extra time, so we come in on Thursday, we could kind of go over everything.
Sounds like a plan.
Awesome. Thanks, guys. I think that's all.
Yeah, awesome.
Thanks. Oh, can you post
See ya.
it for me? Sorry you keep having to do it, but if you could post it, that'd be awesome.